Okay, today you all are going to be working on the practice here on the Euler path. You've got really like 5 questions, but 2 situations, A, B, C, and then A, B. So if we take a look at the first one, it says explain why each of the following graphs has a Euler or an Euler circuit, Euler path, or neither. Provide a degree for each vertex in the graph. So I want you to tell me what the vertex is on each section for the graph. So if I'm talking about A, for example, you go through each one and I would identify, okay, this vertex has 1, 2, 3, 4. So that's a 4 right here. Right, this vertex 1, 2, 3, 4, and again a 4. You can print this, you can draw it. Either way is going to be fine. This one, 1, 2, 3. So you put a 3 and you go through. That is not a vertex. That is just like a overpass, underpass. Here, 1, 2, 3, 4. Here, 1, 2, 3, 4. And then this one again is 3. Now, what I would suggest is going back and looking over all of the theorems that we had for Euler, because in this situation, because we have all the vertices are even except for 2, and exactly 2 of them are odd degrees, then this would be a Euler path. So I'm just going to put Euler path here. Okay. Remember, path is exactly 2 odd degrees. Circuit is all even, and neither is more than 2 odd degrees. So you would go through for B and C and determine what that would be. For part 2 down here, it says find a Euler path or circuit on the graph. Number the edges in the order that they were traveled. So you want to be able to find a Euler circuit or find a Euler path. Now, when you look at these, you can go through and number each one, but it wants you to number the sides that you use in order to find that Euler circuit or your Euler path. Remember, if you're using a Euler path, you need to start at the odd vertex and end at the other odd vertex. So 2, 1, 2, 3, 4, don't start there. 1, 2, don't start there. 1, 2, 3, 4, no. 1, 2, no. Here, 1, 2, 3, 4, 5, that's important. Here, 1, 2, 3, there's another odd. This one is 1, 2, remember a loop counts 2, 3, 4. And then here, 1, 2, 3, 4, 5. Or does it? And then here, 1, 2, 3. So you're going to have to start and go around, right? And then try to find a Euler path or a Euler circle. And then you would number it 1 to each edge that you do until you get to that point. And I miscounted here. This is 1, 2, 3, 4. There's your odd one. So that's where you would start up there. And it's all about the degrees, all about the degrees. So you could start here and you could, that would be 1, down here 2, right? And then you can keep going to get the rest of these. Maybe that's a 3, 4, 5, 6, 7, 8, 9. Now you're back where you started and you can come up 10, 11, 12, 13, 14, 15, 16, 17, 18. So you should have 18 numbered, and that would be a Euler path. Then that means over here, it's either going to be a Euler path or it's going to be a Euler circuit, one or the other. But remember, start and end at the same spot. So that's the 2 that I'll do for you. Make sure that you number these as the path that you take so I can see your path as opposed to maybe someone else's path. And then submit that. And once you're done for today. And again, this is the Euler circuit and Euler path.